In this video, we're going to look at AMP-dependent protein kinases. So all of our metabolic pathways that we talked about in this class are affected by ATP, the need of ATP. In truth, they're actually affected by AMP. So when ATP is broken down, you're going to make AMP. Normally, you don't have a lot of AMP around, so if you break down ATP, the level of AMP will skyrocket and start to affect other proteins. So a lot of proteins are affected, are activated or inhibited by AMP. What we're going to look at today are AMP-dependent protein kinases, AMPK, which will go and phosphorylate other proteins. So AMPK can activate metabolic breakdown pathways because we're low in energy, so we're breaking stuff down to generate ATP, and it will also inhibit synthetic pathways because synthesis needs ATP, and if we're low in ATP, we don't want to start building things up. Now, AMPK is an alpha, beta, gamma heterotrimer. So it's three different proteins making one protein, and each three subunits of that protein is unique. The alpha subunit has your serine threonine protein kinase domain. The gamma subunit has sites for control activation by AMP and inhibition by ATP. And for AMPK's kinase domain to actually work, it has to be phosphorylated for activity. And so AMPK is phosphorylated itself by a kinase called LKB1. And we know this because if you have a mouse and you knock out the LKB1 gene, you do not have phosphorylated AMPK anymore. Now let's take a look at what AMPK does. So AMPK can activate glycolysis in heart muscle, and it does this by interacting with PFK2 and FBPH2, which, if you remember from gluconeogenesis, those videos, you're going to control your fructose 2,6 bisphosphate concentrations. This will activate PFK2, which will increase F26P, which will then increase or activate PFK1 and then turn on glycolysis. So that is our pathway in which we can turn on glycolysis by a protein that is activated by AMP. AMPK can also inhibit lipogenesis and gluconeogenesis in the liver. Again, AMPK is turned on when we have AMP around. AMP means we are low energy. Don't build things if you're low in energy. And it does this by inhibiting acetyl-coenzyme A carboxylase, or ACC, which is our first step of fatty acid synthesis, if you remember that from our fatty acid synthesis videos. It can also inhibit hydroxymethylglutarate coenzyme A reductase, which is used in cholesterol, so we're going to stop the production of cholesterol, and will also inhibit glycogen synthase, which is the rate limiting reaction in making glycogen, so stop making glycogen. AMPK will also promote fatty acid oxidation and glucose uptake in skeletal muscle. So uptake glucose, start breaking down fats. It will also inhibit ACC, which will decrease the amount of malonyl coenzyme A that you're using to make fatty acid. Your malonyl coenzyme A malonyl coenzyme A also inhibits your carnitine palmitoyl transferase, and so when you're decreasing the amount of malonyl coenzyme A, you're turning on carnitine palmitoyl transferase, which will allow more palmitoyl coenzyme A to be oxidized, which means we're breaking down fats to create energy. AMPK will also turn on GLUT4, or will allow GLUT4 to be expressed more. And as we saw in our previous videos, GLUT4 is what is taking up glucose for us. AMPK will also inhibit lipolysis in adipocytes, and it will also inhibit some hormone-sensitive triacylglycerol lipase in adipose tissue. This means that we don't have as much fatty acid being broken down and exported to the bloodstream, which might seem counterintuitive at like we are low energy. Why aren't we sending out fatty acids? Well, researchers think that we just want to decrease the amount of fatty acids that are being released, because if we release too much fatty acid into the bloodstream, that will become toxic and could kill you. So it's more of a regulation factor of, okay, we're low in energy, but don't flood the system with so much fatty acid that the organism will die. So taper back on the amount of fatty acid that you are releasing. And with that, that ends this video. I will see you in the next video.